Okay, I'm going to demonstrate a small device driver for OpenVR that emulates the right hand in space and animates between a fist pose, or actually pops between a fist pose and an open pose. And the idea is to have a minimal known good driver that can be used for different purposes, testing, comparisons, maybe as a reference. So the project is on GitHub. I'll put a link down below. And this is the part that I'm working on right now. It's a bit of an introductory video. Just to make sure there's no wires or to make it a real demo, I'm going to clone it. So this will bring it down. And I'll open it up in Visual Studio. And so in Visual Studio, there's not too many source files. The main there's bones.cpp, which is just a list of bone configurations. These are actually copied from the Knuckles bone states. So I have one for what the Knuckles driver uses for an open hand and what the Knuckles driver uses for a fist, and I just copy the quaternions and positions into tables. Driver log, this comes from the sample. It's just a way to sprint to send messages out to the driver log. Just wraps around the bn sprintf stuff. And then the main part of the driver is right hand test. And so overall this is not a very big file. It's meant to be small, so it's around 200 lines. And it's divided up in basically 3 sections. So right at the bottom there is the HMD driver factory. That's the entry point into the driver. The way that Steam VR's runtime works is there's a registry of directories. So if you want to add a driver, you need to then tell SteamVR about your directories, and then SteamVR will then, or the VR server at startup will open up that directory, look in to see that your driver is enabled, and if your driver is enabled, it'll open up the DLL for that driver. And then once it's opened up the DLL, it then goes into this HMD driver factory and asks, like, do you have this interface? Do you have that interface? And if you have it, then you provide it back, and then that lets the VR server continue talking between your device driver and itself without having to go through a lot of that handshaking. So in this example, all I'm doing is providing a tracked device provider version. Well, this long string here represents a class like this, that interface that provides those interfaces that are defined in that header file. What a device provider does, I guess I'll hold back for a second. So there's the DLL entry point. That's this factory, and from that you give, or in this case we're going to give the VR server a way to know about new devices being created, and that's with a device provider. So the device provider, when it knows or hears about a new device, for example, if it's on Wi-Fi or if it's on USB, it can figure out that there's a new device that's available. Its job is to then pass that up to the VR server to tell it when that device is done. In this test case, all I'm doing is calling track device added right at the startup. I'm not trying to do dynamic detection of devices coming and going. All I'm trying to do is set up a test where the right hand, as soon as this driver goes, is going to be present. It's going to be present for the whole lifetime. So that's all this provider does. And then the last of the 3 sections is the actual device driver itself for the right hand device. He also inherits from iTracked, or from an interface called iTracked device server driver, which is just basically, if you look at this, it's a tracked device. So he will listen, or she will listen to messages like activate and then carry on. So activate actually is one of the more important phases of your driver. So when if your server's opened up your device DLL, it knows about the provider. Your provider's told VR server that you're going to add a device, and now OpenVR is about to, or SteamVR is about to activate it. So it calls into this activate function, and this activate function sets up a bunch of properties. The properties sit some in code. I guess the key, more the key values, top identifying values would sit in the code, like the name of the device driver, which in my case is called right hand test, and then other ones sit on the drive. So I'm setting a bunch of properties, and then because I'm doing this really simple device, I'm just creating one component, the skeleton component, which represents the hand. If you had a more fancy device like buttons, you would add boolean components. If you had some touch interfaces, you might add some scalars. If you had haptics, you could add haptics. These are all just different kinds of device components that you can tell the VR server about. So again, so I'm coming in, I'm being activated. The VR server knows that I exist. It doesn't know exactly what I am, so I tell them through properties what I am, and also a bit of the device that I have. And the last thing I do in here is I start the thread. I start the thread in this case because, or at this point, because I want to know that the device has been activated. I don't, like if the thread gets started before it's activated, that's just asking for extra trouble. In fact, that's actually what I'll look at next is the thread, which is called update pose thread, which sits forevermore waiting while it's active. If the VR server is shutting down, there's a call up there called deactivate, and it'll set that flag to false, and then it'll fall out of this part of the thread. And what this thread does is updates the controller pose. A controller pose is just the pose of the controller in space, not including the hand. And then the hand skeleton poses are the actual bone positions. So if you're using forward IK, you would know all of the rotations and be able to then compose what all the bone positions are. If you're using inverse IK, or then you'd be doing what Valve does with their devices. Like they know their sensor positions know that these buttons are being pressed, so that it can infer that that's where your bones are. In our case, or my case, I'm not doing any of that. I'm just like, okay, well, time's up, I'm going to do the fist. Time's up, I'm going to do it open. So that code sits right up here. Let's see. This one line here. If the frame count is mod 200 less than 100, so basically if it's from 0 to 100, then it's going to be one state. If it's 100 to 200, then it's going to be another state. So I'm just every 100 frames, it's going to toggle back and forth from right hand pose to right fist pose. And a frame, I guess, is defined in this case as just being attached to this timer here, 16 milliseconds. So that's 60 frames per second ish. Alright, so that's pretty much all of the driver setup. Within Visual Studio I need to build it, so I'm building the DLL. And it's a 64-bit DLL, and what I see at the bottom here is it built the DLL. And then I have a DOS batch file that I run to install it. There are probably other ways to do this depending on where you are in your development. It would be possible for you to open up that DLL directly from where Visual Studio builds it. I usually don't. I usually keep that separate. I build it and then I install it. I just have to remember and I build that muscle memory between building and installing to know that the thing that I'm running is the one that I built. It gives me a little bit of control. I want the VR server to be sort of separated a little bit from my development side of things. So anyway, from the alright, so I'll just open up a prompt. You probably can't see that. Alright, that's a bigger font. This is where I put the stuff that I pulled down from GitHub. If you look in here, there is a install driver.bat, and that's the thing that's going to install it. What this does is figures out where the tool that Valve provides to register directories, like what path that's in, and then calls it and installs this directory as one of the paths to search. And I'll show you what happens when I run install driver. So what install driver does is it shows all of the places that currently drivers are being searched, and this includes the one that I just added. There's also a uninstall script which uninstalls it. So it's first it's there and it's not. So just to demonstrate, so if I open up slowly but surely, open up SteamVR, compositor starting, I know that because the screen went blank, and then you can see that there's nothing really interesting in terms of devices being shown. The headset is probably somewhere on my desk, so it's not really awake yet. And then there's two devices that aren't there. If I shut this down and then go back to this and install my driver, so it installs the driver, and I start SteamVR up again, we should see the device driver running. So there, see this green hand. So that's an icon that I drew that it sits inside of the same directory. I guess I could show you that. I guess make sure you can see there. So see demo, right hand test. There is a bunch of folders down here that includes icons. So those icons that are sitting there are the ones that are showing up in here. So hooray, so the driver's working, and there is a right-hand device on that's present inside of SteamVR. If I was to go and start Moondust, let's see, we should be able to see that hand being present in Moondust because it's a controller. And that's the point. The point is to be able to create devices for games that don't necessarily know about your device ahead of time. So Unity is loading. Alright, Moondust started up. I should go find the headset. Alright, headset is here. So if I look around the scene, there, that fist is the hand that is being generated by the driver. So the location in space doesn't move because it's not attached to any sort of tracking system. It's just attached to a fixed location. What I do in the code is I grab the HMD position and then just do some offsets, so at least it pops up and it's not going to pop up in front of your face, and then it's going to go back and forth. I'm not sure, so I guess what else I should show you from here is probably configuring the controller. So this is the bindings GUI, and the thing to look at in here is this setup where there are, on the right hand side there's this control, this right hand test is the controller. This little box here represents actually a list. It's not one thing. These are actually all of the things that could possibly be active right now. So like an index controller, I can associate buttons and also associate the skeletons with this device. For the right hand test, if we go into edit it, it's going to be super simple. There's not going to be very much to it. It's funny, it does show the left even though there is nothing on the left. I'll enable mirror mode. No, I don't want mirror mode. And then I can edit the skeleton, and I can see that the right skeleton, his pose is mapped to the right pose of the controller. So this is probably confusing, but what's happening on the left hand side, this right skeleton is saying, okay, as far as the game is concerned, what does that map to? And in this case, because I've got this binding set up, it's mapped to my right skeleton. If I wanted to map it to something else, like another controller actually, I could do that. So that's the skeleton mapping, and that's the bones of the hand. The other thing to look at in here is the action pose positions, and that's not the bones, that's the actual device itself. So that's connected to the pose. So I guess to summarize, this is like a really quick view of the bindings interface and how I'm associating the two concepts in the game, the pose of the device and the hand skeletons of the device, with two equivalent things that are inside of the driver. It's important because in setting up bindings, there's nowadays there's three people involved. There's the people writing the drivers who publish the things that they need to, that they're offering to be bound to. There's the game, which is publishing the game actions that they want, or semantic actions that they care about, and then there's the user who sits in between them. So there's three people that are involved in setting up a binding, and this system can be a bit well, it has a bit of a learning curve. Anyway, I don't want to get too distracted on that, but it would be silly for me to ignore that. So that's the bindings interface. That's the Unity running. I suppose the third thing that I should show is Unreal. So just recently, Unreal has also got support for these actions. So if I can find the Unreal Engine, start it up, and we should be able to see this hand in game. So what takes longer to load, Unreal or Unity? I would say it probably depends on the scene. That's what I would say. Alright, so the scene, well, I haven't even loaded the scene yet. So the scene is called Wednesday. It's the stock scene. The only difference is that I was playing with the spawning of cubes. So if you look at one side when the scene starts playing, there's cubes that are just stacking on top of each other in the back hand corner. Alright, so this is what Unity looks like. If you look at the top of the Unity, there's now this, well, if you do the plugin steps, you set up SteamVR input, and it comes with two maps. The map that I'll show you is this Unreal Engine hand sample map. Alright, we'll go and play. So there it is. That's the same device again. So it's a different model. So like that's Unreal Engine's hands, but it's doing the basically the same thing. The demonstration driver is just occasionally popping and showing closed fist and open hand. So I guess those are three areas that I'm demonstrating of the driver being able to participate in. So it participates in the Unity engine, it participates in the latest sort of Unreal stuff, and also in the bindings interface. Those are three things that you need to get right. And I think that's all for now. Well, actually, I should show, I guess to close it down, I should uninstall the driver. So this is actually pretty important, because if you're developing and then you have somebody and they want to play something, you want to be able to get in and out of it pretty easily. So having a nice and fast install and uninstall is helpful. Alright, thanks for now.